What's up, geeks, and welcome to the channel. Today, we're diving into an elegant and frequently asked coding problem from LeetCode titled Keys and Rooms. It's a clean yet clever challenge that boils down to a simple question. Can we visit every room in a locked hallway, starting with just a single key? Let's set the scene. We're given n rooms labeled from 0 to n-1. All rooms are locked except for room 0, which is our starting point. Once we enter a room, we might find a set of keys inside. Each key corresponds to another room in the hallway. Our goal is to determine whether we can use the keys we collect to eventually unlock and visit every single room. Let's take a quick example to bring this to life. Imagine we have 4 rooms. Room 0 contains keys to rooms 1 and 2. Room 1 has a key to room 3. Rooms 2 and 3 don't have any keys at all. Starting from room 0, we enter and pick up keys to rooms 1 and 2. We now unlock room 1, grab the key to room 3 and proceed there. At this point, we've stepped into all 4 rooms, so our logic should return true. Now, let's talk about the first solution, one that relies on a queue and follows a breadth-first strategy. This is essentially a BFS style approach. We use a queue to simulate visiting rooms using the keys we gather along the way. To begin, we keep track of the rooms we've already unlocked by using a set. Room 0 is added to it right away since it's open from the start. We then initialize a queue and drop in all the keys we found inside room 0. Now, we begin processing the queue. We take a key out, check if the room it opens hasn't already been visited, and if not, we add it to our visited set and load all the new keys from that room into the queue. This process continues until the queue is empty. If by then we've visited all rooms, we return true, otherwise false. This can be done by checking if the number of keys retrieved is equal to the number of rooms we have to open. Let's break it down with a bit more detail. Suppose our rooms are arranged similarly to the example we had at the beginning. We added room 0 to our visited set. We then queue up keys 1 and 2. First, we pull out key 1. Since we haven't visited room 1 yet, we go in and collect its key to room 3, adding it to the queue. Now, our queue contains the values 2 and 3. Next, we process key 2, we unlock room 2, find nothing, and move on. Then we handle key 3, unlock room 3, and find nothing again. Our queue is now empty and our visited set includes rooms 0, 1, 2, and 3, so we return true. This approach is rooted in breadth-first search because we're expanding outward layer by layer, room by room, using a queue structure typically implemented with a deck in Java. Now, let's shift to a different mindset and look at a recursive approach. This one leans on depth-first search, or DFS. We start with room 0 and mark it as visited right away since it's the only room open from the beginning. Now, inside room 0, we find a set of keys. Each key corresponds to another locked room that we might be able to enter. For each of these keys, we check if the room it unlocks has already been visited. If it hasn't, we immediately go inside that room. This means we mark it as visited and make a recursive call to explore it. This process ensures we are diving as deep as possible into one path, unlocking rooms one after another before we backtrack to previous rooms to explore any other unexplored keys. By the time all recursive calls have finished, we'll have marked all rooms reachable from room 0 as visited. If all rooms are visited, it means we successfully unlocked and entered every room, so the answer is true. Otherwise, some rooms remained locked and inaccessible, so the answer is false. Again, imagine the same 4-room setup. We enter room 0, find keys to 1 and 2. The recursion first picks room 1, enters it, finds a key to room 3, and goes into it. Room 3 is empty, so we backtrack to room 1 and eventually back to room 0. Now we explore the second key from room 0, key 2, and enter room 2. By the end of this recursion, we check if all rooms have been marked as visited, which is indeed the case, and return true. It's a clean and intuitive strategy. Instead of using an external queue, the recursive call stack keeps track of our exploration. The rooms visited can be marked using an array or a set. We used an array here to showcase both options. Okay, both solutions share the same goal. Keep track of rooms we've visited and try to reach them all using the keys available. In terms of complexity, both perform similarly. Each room and key are visited or processed at most once, so the time complexity is O of n plus k, where n is the number of rooms and k is the total number of keys found in all rooms. Now, you might be wondering, when should we choose BFS over DFS or vice versa? Both methods will get the job done, but they each have their own strengths and intuitions that can guide our choice. Breadth-first search, or BFS, is like exploring a building floor by floor. We visit all the rooms closest to us first before moving deeper. This makes BFS great when we want to find the shortest path or the minimum number of steps to reach a target. On the other hand, depth-first search or DFS dives deep into one path before backtracking. It's like walking down one hallway until we reach the end, then returning to explore other hallways. DFS can be easier to implement recursively and sometimes feels more natural when we want to fully explore one branch before moving on. In this keys and rooms problem, since we just need to know whether all rooms are reachable, either approach works perfectly. But if we ever need to find the shortest path or the minimum keys required to reach a room, BFS would be the way to go. For simply checking connectivity or reachability, DFS's recursive elegance might appeal more. The link to the LeetCode problem we solved today can be found in the description below. Let us know your thoughts and suggestions for upcoming videos in the comments section. And that's it for this video. I hope it was helpful. If you learned something new today, hitting the like button and subscribing really helps the channel out. Thanks for watching, take care, and I'll see you in the next one.